So let's use Cramer's rule to solve a linear system of equations in two variables. So let's say I give you 2x minus 3y is equal to 8 as the first equation, and then 5x plus 6y is equal to 11 as the second equation, and I want you to use Cramer's rule. Oops. So use Cramer's rule. Now remember, in general, if you have a regular system of linear equations, so ax plus by is equal to c, and then dx plus ey is equal to f, Cramer's rule is given by x is equal to dx over d, and y is given by dy over d. And if you recall, the way to find d is to do a 2 by 2 determinant matrix with the coefficients in x and y. So the first column would be a and d for the coefficients in x, and the second column would be b and e for the coefficients of y. Now dx, you still do a 2 by 2 determinant, but instead of the x coefficients, you replace the a and d and the x coefficients with the constant terms. So instead of a and d, you're going to see c and f, and then the y coefficients are the same. And then for dy, you do the same thing, except instead of a and d, you now replace the y coefficients. So the x coefficients are going to be the same, but the y coefficients are going to be replaced with the constant terms. So knowing that, let's use Cramer's rule to solve. So first thing we should do is find d, dx, and dy. So d is the coefficients in x as the first column, and the coefficients in y as the second column. So that's 2, 5, negative 3, and 6. And remember how we solve a 2 by 2 determinant is that you cross multiply and then subtract and then take the difference. So you cross multiply 2 and 6, and you subtract the cross multiplication of negative 3 and 5. So using PEMDAS, let's do the multiplication first before we subtract. So 2 times 6 is 12, minus negative 3 times 5 is going to be negative 15. So this becomes 12 plus 15, which is 27. So now we have d is equal to 27. Great, let's find dx now. Dx, let's look back upon the system of equations. Now dx, you replace the x coefficients with the constant terms. So instead of 2 and 5, we're going to write 8 and 11, and then the y coefficients stay the same. So we get negative 3 and 6. So now, solving this 2 by 2, we get 8 times 6 minus negative 3 times 11. This becomes 48 minus negative 33, which is what negative 3 times 11 is. So 48 plus 33, and that becomes 81. So now we have our dx, and finally we just have to find our dy. So dy, let's go back to the equation. You write the x coefficients the same, leave them alone, but in this time, for the y coefficients, instead of writing negative 3 and 6, you replace them with the constant terms. So as the second column, we're going to get 8 and 11. Great, so now doing this, we get 2 times 11 minus 8 times 5. And simplifying, we have 22 minus 40, which gives us negative 18. Awesome. So now we have d, dx, and dy, and so now we just have to put them together to find x and y. So x is dx over d. We found dx to be 81 and d to be 27. So that's 81 over 27, which simplifies to 3. And finally, y is dy over d, and dy is negative 18, and we know d to be 27. And then finally simplifying that, this becomes negative 2 over 3. So finally, since we usually express our answer in terms of the ordered pair x comma y, you want to write the solution to the system is negative 2/3, comma 3. Oops, sorry. Caught myself there. 3, comma, negative 2/3. I'm sure you were all correcting me. But there you go, x comma y, right? X comma y. Perfect. Alright, so that's our solution.